Dear friends, in daily life situations, we come across various sequences of numbers which form interesting patterns. In mathematics, the study of these patterns leads to beautiful generalizations. A sequence may be thought of as an ordered list of numbers, ordered in the sense that the order of various terms in it cannot be changed. In daily life, examples of sequences are found in abundance. The population at any given time increases in a sequence. Radioactive materials decay or disintegrate in a sequence. Our accounts in the bank increase in a sequential manner. A sequence such as these, which follow certain patterns, is called a progression. In this series of programs, we shall study certain particular types of progressions called arithmetical progression and geometrical progression. In this particular program, we shall concentrate on the concept of arithmetical progression. So today's topic is arithmetical progression. Before we start to learn formally what is an arithmetical progression, we need to understand a sequence mathematically. So what is a sequence? Let's define it formally. So I write the definition of a sequence. A sequence is an arrangement of numbers in a definite order according to some rule. So the order is important and this rule is important, and we have a sequence of numbers. I shall write down some of the examples of sequences. So let's think about this: 0.1, 0.11, 0.111, 0.1111, and so on. Let's take this sequence: 2, 3, 5, 7, 11, and so on. We can have another sequence like this: 1, 1, 2, 3, 5, 8, and so on. Yet we can have some sequence like, say, 100, 120, 140, and so on. We may still have another sequence like 1, 1 by 3, 1 by 9, and so on. Now all these sequences, they have certain patterns inbuilt in them. If we look at the first sequence, it is 0.1, then it is 0.11, then it is 0.111, and so on. Every time a 1 is increasing after the decimal point. Now if we think mathematically, this sequence is obtained by dividing 1 by 9 and taking the quotients at various steps. The sequence at number 2 is the sequence of all prime numbers which are not divisible by any other number except the same number. The sequence at 3 is a special sequence which is called Fibonacci sequence. Now here the terms form a pattern. The first term is 1, second one is also 1, and the terms after that, they are obtained by adding the previous two terms, like 2 is 1 plus 1, 3 is 1 plus 2, 5 is 2 plus 3, 8 is 3 plus 5, and so on. The fourth sequence, each term is increasing by 20 from the previous term. And in the fifth, the consecutive terms, they are multiplied, they are the multiplication of the previous term by 1 by 3. So all these sequences, they have certain inbuilt rule by which we can write down the next terms. Now when we talk of the sequence, there are certain numbers which belong to a sequence. These are called the terms. So first term we usually denote by T1, the second term we denote by T2, and the general term we denote by Tn. General term Tn, which is also the nth term of a sequence for any natural number n. Now given a sequence, we can always write a formula for Tn, or we can think of Tn in terms of some inbuilt rule. For example, for the sequence at number 2, we cannot think of an explicit algebraic formula for the nth term, but we know that it is the prime number, nth prime number, which occurs in the sequence of natural numbers. For the third one, again we don't have a formula which can give the nth term explicitly, but we can write down the nth term as the sum of the previous two terms for n bigger than or equal to 3, but for that we need to define the first two terms explicitly. So if we take this as the definition of the first two terms and Tn as this, then this recurrence relation will give me this sequence. Similarly, these sequences will have their nth term defined explicitly as an algebraic formula. Now a sequence can be finite or infinite according as the number of terms in a sequence is finite or infinite. If the number of terms is finite, the sequence is said to be finite. If the number of terms is infinity, right up to infinity, then it is called an infinite series. Now here the series 1, 2, 3, 4, 5, if I have written it like this, then all these are infinite series. But suppose in place of 4 and 5, I just write down the series 4 dash 100, 120, 140, 160. Then this is a sequence in which I only have 4 terms. This is a finite number, therefore this is a finite sequence. Another definition of a sequence could be thought of as a function. Now let me write down the definition of a sequence as a function. A sequence can be thought of as a function whose whose domain is the set of all natural numbers this is in case of an infinite sequence. For every natural number we have a number which is the corresponding element of the sequence, or a subset of natural numbers of the type 1, 2 up to k. Now if we have a finite subset and we take a function which is defined whose domain is this set, then we get a finite sequence. Now let us take up some examples. Now given Tn, let's try to find out the first few terms. Say Tn is 2 raised to power n minus 1. Can we find T20? This is simple because we simply have to substitute n is equal to 20 in this explicit formula and we will get the 20th term. So T20 will be simply 2 raised to power 20 minus 1. So you have to compute 2 raised to power 20, which is going to be a large number, and the final thing you can get the answer. Now similarly, if you have a sequence which is defined like, say, Tn, T1 is equal to minus 1 and Tn is equal to, let's define it by Tn minus 1 divided by n minus 1. Now this gives me a recurrence relation. If we have to find, say, T4 in this sequence, how will we go about it? T4 will be cannot be found directly from here, because if I put n is equal to 4, I will have T4 is equal to T3 divided by 3. So I need to have the value of T3. But how to calculate T3? T3, when I put n is equal to 3, I will get T3 minus 1 divided by 2. So I need to compute T2 for that. And for T2, I need the value of T1. So I'll have to go one by one. So I will find T2 first, and T2 will be by simply putting n is equal to 2 here. So it will be T1 divided by 1, which is equal to minus 1 divided by 1, which is minus 1. Now I go to T3. T3, I substitute the value n is equal to 3 in the formula, and I get this as T2 by 2, which is equal to minus 1 by 2. And T4, I will again get from the same formula by substituting n is equal to 4. I get this as, so I get minus 1 by 2 divided by 3, so it is minus 1 by 3 factorial. So this is how, given a recurrence formula, we can find the nth term. Now with this background material, I think we are ready for the study of arithmetical progression.